Now I want to talk about a heat pump system. The heat pump system has the same components. It has an evaporator and a condenser. The evaporator is absorbing heat from a low temperature source. What does the condenser do? It has to reject heat to a high temperature source. Same thing. Hold it. This looks like exactly like a air conditioner, refrigeration cycle. It is. But the goal of the heat pump, this is what you desire. You want heat dumped into something that's already warm. And you're going to purchase maybe some electricity, and maybe this is the inside of your home in the middle of winter, and the outside of your home is a cold winter day. And the first time you hear about it, you say, this is ridiculous. Why did the engineer think that they're going to be able to make the outside colder and use that heat out of the outside plus the electricity to make the inside of my home warmer? All right, so you recall, what is our coefficient of performance for a heat pump? It's still the ratio what we desire, but this time we want either lowercase qh or q dot h, depending on how you want to describe it, divided by the lowercase w into the compressor or w dot into the compressor. That's what we desire. All right, let's do this. Before, maybe I supplied 1 kilowatt of power. Maybe I'd put W dot there, cap W dot compressor. I supplied 1 kilowatt of power. And I was able to remove from the low temperature, 2 kilowatts of rate of heat transfer. How much is supplied to the high? Is it 3 kilowatts? With confidence, it's 3 kilowatts, right? Now, what is the coefficient of performance for this heat pump system in this case? COP of the heat pump is 3. All right, let's say that the perspective is it really is a refrigeration system. COP of the refrigeration. What is the COP of the refrigeration for the exact same working conditions? 2. And now you see a pattern. It's easy to establish that the COP of the same system operating the same conditions, if you look at it from the perspective of being a heat pump, is 1 plus the COP of looking at it a perspective being refrigeration. It's just 1. Okay? All right. Let's continue on. So you have a... Yes, sir. Okay. So the federal government wants to help people, consumers, make good purchasing decisions on heat pump systems, so they have a heating seasonal performance factor. And it's, look at this, it's some sort of efficiency. It's the ratio of BTUs of heat output over the heating season to watt hours of electricity used. So take a look at the units on that. You have HSPF equal to the BTUs of heat output divided by watt hour. Depending on the system, this factor can be 8 or greater. And the higher the number, the better it is for efficiency. Let's take a look. Here's an energy guide. It's for a heat pump. It's actually cooling and heating. So when you're wanting to replace that air conditioning system, the salesperson may come to your house and say, look, we'll put in a heat pump system. We'll get rid of the inside furnace as well as the condensing unit on the outside. And now this system will be really efficient. It'll be a heat pump system. All right. It's a split system, meaning that it has an outdoor unit and indoor unit. All right. There's a manufacturer. Look they give us the SEER. That's a pretty good SEER, right? 15. And what do they give us right here? Seasonal heating performance factor. All right. And they try and show you on a scale of, comparable units, you could buy a more expensive, higher efficiency unit. All right. If a heat pump has 8.2 HSPF, what is its equivalent COP? And we'll go ahead and start. How much time do you think you need? 1 minute? 1 minute. I think time is out, is it not? Should we just take a look at the results? All right. So why is 2.4 the right number? Units. You're just converting units. You had to use either one of these factors to convert the units. True? So you had the 8.2, which is BTU per watt hour, and you multiply by 1 BTU per hour is 0.293 watts. Get rid of the hour, the BTU, the watts. It looks like it's 0.3 times 8.2. Does that give us the 2.4? Make sense? Are people clowning with me on the D's and E's and C's, or are you just trying to learn? Because I'm gonna look at this when I cut final grades. I'm not using it for extra credit. I just promise you I'll look at the last half of this class at our clicker participation. And